Let's begin by taking a look at a problem out of 2.1 from homework. Let's look at number 3. It gives us a stem and leaf display. And I'm going to copy this information over. It tells us a little bit of information at the top to begin with. It tells us, goes ahead and tells us, hey, it's a stem and leaf. Tells us how many data points we have, and we could check that if we count it up. This is the stem, these are the leaves, so if we count the number of leaves, that should correspond to the number of data points. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data points. And then also notice it tells us what our leaf unit is. So if it tells us what our leaf unit is, that means the numbers that are on the leaves, those are in our case, those are in the hundredths position. So that represents 7 100ths. Our stem is 59, so let's look at this first stem, this first number, 59 with a 7. In order for the 7 to be in the hundredths place, our decimal would go here. If we look, for example, at this number, the stem is 62, that leaf is 7. In order for our leaf to be in the hundredths position, the decimal would go there. So these numbers range from magnitude of 5.97 up to 6.43. So that lets us kind of see what the range of values are. So if we look through the questions, first part, what is the meaning of the leaf unit? 0.01. That's the place value of the leaves. Tells us that they're in the hundredths position. Second decimal place is the hundredths position. How many data values are shown? That's what we're told here. There are 16 data values shown. And then asks us to list the first 4 data values. So we've done 5.97, and then the next one will be 6.02, 6.03, 6.09. And that's what they have. So you just write out the stem in each leaf. So 60, then 2, 603, 609. You list those, and then you put your decimal so that your leaf, so this has 3 leaves, this is 1 leaf, so this represents 3 different numbers, 602, 603, 609. We put the decimal so that each of the leaves are in the hundredths position. Then ask, what are the column of numbers down the left-hand side here? Kind of odd the way they have this laid out. So at this point we have, in this row we have 1 data value. In this row we have 1, 2, 3 data values. Here we have 1, 2, 3, 4, 5 data values. 1, 2, 3, 4 data values. 1, 2, and then 1. So notice that these numbers correspond, but then these numbers don't. This is actually the total of those 2. This one, that corresponds. This one corresponds. This number is actually the total of these 2. This one is the total of those 3. So this is kind of laid out peculiarly. We wouldn't necessarily do it like this. Often we don't include these values. But these are the cumulative totals starting at the beginning and these are the cumulative totals starting at the end. So from 6.43 down to the lowest here, 6.35, that's a total of 3 data values. So this means there are 3 data values from here and larger. This means there are 7 data values from here and larger. This means there are, from the largest one here, there are 4 data values from there and smaller. Kind of a peculiar way to lay that out. So those are basically the cumulative frequency. When we're talking about data, frequency is just the count of how many times something occurs. So if you want to know what is the frequency, what is, let's say, this number, notice that's repeated 2 different times. That's the number 616. The decimal is here, so that's in the hundredths place. The frequency of this data value is 2. That particular data value occurs twice. If we wanted to know what is the frequency of data values that include, for example, 6, 1 as their leading numbers, there are 5 data points that have 6, 1 as the first 2 numbers. Now those numbers are not all the same. Some of those are 6, 1, 0. Some of those are 6, 1, 2. Some of them are 6, 1, 6. One of them is 6, 1, 9. So, but there are 5 values that occur in this region. So the frequency of having 6.1 as the leading 2 numbers, that frequency, the number of times that occurs is 1, 2, 3, 4, 5 times. All right, now let's continue. Let's look at 2.2. Let's look at one of the homework problems out of 2.2. And in 2.2, we're looking at frequency distributions. So let's look at this example. I don't think I copied that very well. This was 7.7, 8.2, and 9.0. So we have values ranging from our smallest is 4.0, our largest looks like is 9.2. So we have 40 different values in this group, and instead of putting these into, instead of counting up how many 4.0s, how many 4.1s, how many 4.2s do we have, that wouldn't be very necessarily profitable. Some of them are repeated, yes, but there's not a huge difference between 5.5 and 5.6, for example, or 6.5 and 6.6. Those are relatively close. So what they've asked us to do is group these into classes or bins. When you think about a bin, I think about a box, like a laundry bin or a mail bin. That's just a group, a place to store similar items. So the first part of the question, they ask us to count up how many fall into each of these classes. see, let's copy this over. So as we go through this, I'm just going to kind of tally up how many we have in each category. And notice it almost looks like these two overlap. It's very important that our bins or our classes don't overlap because we don't want the same data point to fall into two different categories. We want each data value to fall in just one category so that if we were to add up the total number of values in all of the categories, it should equal 40. It should equal our number of data points that have been collected. So we don't want any of them to be repeated. We want each data value to be accounted for one time. So 4.7 can't go into both of these. 7.7 can't go into both of these. So when they say 3.7 to 4.7, they mean that it includes 3.7, but it doesn't quite include 4.7. It includes everything right up against 4.7. And then the next one includes 4.7 and everything up to 5.7, but not including 5.7. And as a researcher, you have a little bit of flexibility to determine, well, which end do you include? Do you include the left end? Do you include the right end? Or do you include both? Depending on what kind of data you expect, you can determine how you want to set up your classes or your bins to fit your particular scenario. Sometimes you might want to set it up where you include both ends. Sometimes you may want to set it up like this where you include one end but not the other. It could be that you include the right end but not the left, or it could be you include the left and not the right. So if we go through here and tally, I'm just going to look at the first column. We don't have any values in the first column between, we could do this a couple of ways. Let's just actually do this. Let's go through each data value and put a mark in the category it falls in. So 6.5, that falls in that category. 5.0, that's here. 5.6, 7.6, that's here. 4.8, that's there. 8.0, 7.5, 7.9, 8.0, 9.2, 6.4, 6.0, 5.6, 6.0, 5.7. Remember, we're not including the upper boundary, so we're not putting 5.7 here. We are including the lower boundary, so 5.7 would be here. And 9.2, 8.1, 8, 6.5, 6.6, 5.0, 8, 6.5, 6.1, 6.4, 6.6, 7.2, 5.9, 4.0, 5.7. 5.7, that's one of those boundary items. We're not including the upper boundary, we are including the bottom one. So 5.7 is in this one. 7.9, 6.0, 5.6, 6.0, 6.2, 7.7. We're not including the upper boundary, so 7.7, that's here. 6.7, we are including the lower boundary, so 6.7 goes here. It doesn't go here because we don't include the upper one. 7.7, again, that goes here. 8.2 and 9.0. So we have 1 in the first category, 5, 6, 5, 10, 15, 16, 4, 5, 10, and 3. So that's the number of values that fall into each category. One part asks for what is the midpoint, describe the midpoint of each class. If we want the midpoint, it's the point that's halfway between those. Anytime we have two numbers that we want the number between them, we add them up, divide by 2. For example, if you made a 90 on the first test, 100 on the second test, halfway between those is a 95. Well, if you add those together, divide by 2, 190 divided by 2, you get 95, which is halfway between 90 and 100. So if we want what's halfway between 3.7 and 4.7, if we want that midpoint, 3.7 plus 4.7 divided by 2. So 3.7 plus 4.7, that's 8.4 divided by 2, so 4.2. So that's the midpoint of the first class. If we want the midpoint of that class, that goes from 6.7 to 7.7. So add the upper and lower ends, divide by 2, so 7.2 would be the halfway point or the midpoint of that class. Then the last thing they ask us to do for this one is construct a frequency histogram. So when we make a histogram, let's see. Often we put our classes in the X direction and then our frequency in the Y direction. So our frequency is in this way, and then our classes this way. So we have 1, 2, 3, 4, 5, 6 classes. So we could let this be our first class, second, and let's actually skip over. This will be our first, second, third, fourth, fifth, and sixth. I put this in there. Don't have to necessarily put that, but that just means there's a break. That when I put 3.7 here, then 4.7, 5.7, 6.7, I think 7 comes after 6, if I can count right. Just means we skipped. We didn't go straight from 0.7 to 1.7 to 2.7. We skipped over, and then we started at our smallest boundary of our smallest class and went to our upper boundary of our upper class. So we go from 3.7 up to 9.7. Now our largest value is 16. So on our histogram, we need to be able to go up to 16. So we could say, let's just do this. So that's 1, and then let's copy this. So that would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And notice I didn't get those perfectly spread out evenly. It should be, but I didn't get them that way. On the test, I'll give you a grid, some graph paper or something that you can use when you're constructing a histogram. So our first class, our first bin has a frequency of 1. So for a histogram, we would construct a bar. It goes up 1. And I'm just going to color that in. Our second class has a frequency of 6. So we'll construct a bar that goes up 1, 2, 3, 4, 5, 6. And then 16. So our next class goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. From 6.7 to 7.7, that's 4. So 1, 2, 3, 4. 7.7 to 8.7, that's 10. 1, 2, 6, 7, 8, 9, 10. And the last one is 3. 1, 2, 3. Notice for our histogram, it doesn't tell us exactly what the data values are like a dot plot. Each bar just tells us the frequency, how many fall into each category. So if I looked at this one, that one goes up 1, 2, 3, 4. So I know in this range, we have 4 data points. We don't know exactly what those data points are. We just know that in that region, we have 4 data points. In this last region, we have 1, 2, 3 data points. Again, we don't know exactly what they are, but we know that we have 3 data points in that region. And this just helps us to see what is the distribution. Distribution just refers to how spread out our data is, or what's the lack of spread. We can see kind of the range of our data, and we can see how it's grouped. So all of those things characterize the distribution, how our data is arranged, grouped, spread out. Notice in general we kind of have 2 peaks, one largest peak, and then kind of a secondary peak. Also, it goes up in the middle, down on the end. So we could talk about, and we'll have sections that discuss averages and things later. Average means lots of different things, but you could say on average, values are between 5.7 and 6.7. That's the largest category, and we can see as we get to each end, we have less and less data on the ends. So this is a frequency. Each of these each height represents a count. If it were a relative frequency, relative just means basically is a percent, means out of the whole, what percent is it? So we could convert these into percentages. We have 14 data points. We want to look at this largest, the largest one. It contains 16 values, 16 out of 40 values. So this largest one contains 40% of our data. This largest class contains 40% of our data. If we looked at this one contains 10 out of 40. that's 0.25 or 25% of our data. So relative, that just means we convert it into a proportion. How does that class compare to the whole? And as I messaged some of you, a percent is just a portion or a part divided by the whole and then converted into a actual percentage. Part, if we just do part divided by whole, that gives us a decimal. And then, of course, we can convert a decimal into a percent. But if we're just going by the count, the sheer count in each category, that's just the frequency or the absolute frequency.